As the name implies, the ozone layer is made up of ozone. Now, ozone is going to be three different atoms, three oxygen atoms. And so we refer to this as O3 or ozone. Now, here's what happens way up there in the ozone. But before we get into that, ozone in the upper atmosphere is really important for us because it protects us from ultraviolet rays. Ozone down here in the lower atmosphere is not good for us. The oxygen that we like is right here. This is O2, and that was much better than this guy, which is O3. So ozone up there, good. Ozone down here, pretty bad. But here's what happens. In the ozone layer, we have our ultraviolet waves, and those ultraviolet waves come down. Now, ozone, O3, has a certain relationship with this particular wave frequency that when it gets hit, it absorbs that energy. Now, energy cannot be created nor destroyed. It gets absorbed, and that causes this guy to just start zooming all around. And it actually breaks apart for a little while. And so what we end up with is O2 and a free oxygen atom floating around. And it happens again and again and again. Boom, 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 boom. And so excited. And then these guys start separating from each other. And then boom. And they all start to get so excited that they start to fly apart. Right? Well, that is good and dandy. It did its job. Eventually, they start to settle back down, and thump, they reconnect as O3, and thump, they start to reconnect as O3, and once again, boom, we're got our stable ozone layer again. And this guy regenerates itself as they start to settle back down and slow back down. We start to get O3 back again, and that's wonderful until we started working with chlorofluorocarbons, or CFCs. Now, CFCs, we use them for a number of different things. Chlorofluorocarbons, I could try to spell it, but it would just be embarrassing. But what happens is in the production of chlorofluorocarbons, there is an enemy amongst it. And that enemy is right here. And this is referred to as chlorine. Chlorine gas. And this chlorine is alone isn't too terrible, but because of a number of different processes, sometimes with the production and the use and the leaking of chlorofluorocarbons, we get chlorine up here in this upper atmosphere. Now, here's what happens. Chlorine doesn't do anything to ozone. So if it were just chlorine, all the UV energy, these UV or ultraviolet rays, as they start to come in, nothing would happen to them. They would just go running through. So here's what happens. They don't really interact so much with the ozone, but when these guys get hit with the UV energy and they start to go crazy, it starts to attract, and we'll turn them the right way, starts to attract these free oxygen atoms. Okay? Now, O2 cannot stop UV energy, and chlorine with a little oxygen isn't going to do that either. It just happened once, but no, it keeps happening. This guy, let's go, and now we've got O2 and another oxygen on that chlorine, and then again, boom, happens again, another O2, and then boom, happens again. Oh my goodness, it just keeps happening. This chlorine is like the handsome fella at the party. Okay? All the girls wound over to him, and all the guys, are impressed with him as well. Anyway, all of these free oxygen start to flow all around. Now, what have we ended up with is a big problem, because we've got this little chlorine cluster right here with a bunch of free oxygen atoms. Does not stop UV energy. And O2, as wonderful as it is, and although we like to breathe it, O2, little 2 oxygen molecules, that doesn't do anything for those UV rays either. And so where this starts to happen, that's where we start to see the UV energy coming all the way through, because there's no longer ozone to stop it. It just comes right on through. Okay? So through the production of chlorofluorocarbons, We get free chlorine atoms that are up there. Those free chlorine atoms start to attract all of the free oxygen atoms, leaving behind O2 and this weird cluster. And none of that is going to be stopping UV rays. That's the problem that we have. Now, have we slowed down our use of chlorofluorocarbons? We have. We are using less of them than we used to. We're now using hydrofluorocarbons, which is probably creating bad gases as well. But we have slowed down our use of CFCs, some of the chemicals that we use in our air conditioners, some of the propellants that we use in cans, other things like that, we're using less. And that's a good thing. Slowly, the UV the ozone layer is starting to regenerate. It's starting to come back together in some places. It's a very slow process, but we are making some progress with all of this, thanks to the scientific discoveries that it was the CFC's fault and the regulations that went into creating less of them.